Okay, let's continue with this conditional probability and do a problem where we use it. So table 1 shows the results of a survey of 1,100 traffic accidents. The data is tabulated according to the cause of the accident and the sex of the driver at fault. So tabulated means we put one of those across here and one of those down here. So we're putting male, female down here and the cause across here. So this is again called a contingency table, in this case a 2 by 2. No, it's not 2 by 2. A 3 by 2 contingency table. Okay? Okay, so we have mechanical failure, intoxication, and poor judgment. So these are three possible causes that they consider. Mechanical failure means something wrong with the car, person was drunk, or they just had poor judgment. Okay? And male and female. So what does this number mean? It means that there were 310 cases out of the 1,100 cases where the cause of the accident was mechanical failure and it was a male who was driving. There were also 280 cases where the cause was mechanical failure and a female was the driver. Now we can also ask, for example, how many mechanical failure cases were there? Well, there were 310 cases male, 280 cases female, so the total was 590. How many cases of intoxication was the cause? 102 for male, 45 for female, 147. Poor judgment, here, plus it gives us this. So what do these numbers have to add up to? They have to add up to 1,100, right? There's only three. And what is this? This is the number of cases for mechanical failure. So what's the probability that the cause was mechanical failure? So the total number of cases is 590, and is 1,100, and we had mechanical failure 590 of those. So the probability that you get a case that's caused by mechanical failure is 590 divided by 1,100. What's the probability that it's intoxication? It's 147 divided by 1,100. You can do the same thing here. How many males were there? 620. How many females are there? 480. So what's the probability that it was a male? 620 out of 1,100. What's the probability that it was a female? 480 out of 1,100. That is, what's the probability that if you choose one of these cases out of the 1,100 cases, you choose one of them, what's the probability that it's going to be a male that was driving? It's going to be 620 out of 1,100. Okay, so they say, given that so now we're talking, so we just did some kind of marginal probability questions, but now we're going to do a conditional probability question. So you know it's conditional when they say given that. So given that the accident was caused by mechanical failure, what is the probability that the driver was male? So how do we write that? So let's give these two events. So there's two events involved. The accident was caused by mechanical failure, and driver was male. So let's give those names. So you do that. A is the event that the driver was male, and B is the event that the accident was caused by mechanical failure. So now we can rewrite this question as the given is that the accident was caused by mechanical failure. So that comes here. That's given. So that's B, that it was caused by mechanical failure. And they ask what's the probability of A given that. So it's the probability that it was male given B. So the question is, now that we gave A and B meaning up here, now we can rewrite the question as the probability of A given B. So that's what we want to know, the probability of A given B. Let's read a little bit more what they write first. So we want to find the probability of A given B. Of the 1,100 accidents, it follows from table 1 that the 310 plus 280 accidents were caused by mechanical failure, 590. and 310 were caused by mechanical failure with a male driver. That is, the probability of B is what? 590 divided by 1100, right? And the probability of A intersect B, why are we doing A intersect B? Because we know that we're going to need that for the formula. So the probability of A intersect B is what? Here's A intersect B. Probability of that is 310 out of 1100. So that's here. Thus, from formula 5, the probability of A given B is this divided by that. That's what we said the formula is. Probability for A given B is probability of A intersect B divided by the probability of B. Now we just figured out what these are. Probability of A intersect B is here, 310 over 1100. Probability of B is 590 out of 1100. So this is the result. So the 1100s cancel. We get 31 over 59. Okay? And that's the answer. They say we can do it a different way, but since we didn't follow this book, I won't do that. What's this? Oh, there's a second question. Second question is, given that the driver was male, what is the probability that the accident was caused by mechanical failure? These look almost the same, right? But they're not the same. Given that the accident was caused by mechanical failure, what's male? And this is given male, what's mechanical failure? So they're not the same. This one we said was the probability of A given B. So this question must be what? The probability of B given A. Right? The first question was A given B. Second question is, where is it? Did I skip it? Here. We want to find B given A. So if we want B given A, we're going to want what? B given A, then this will be B intersect A, which is actually the same thing as A intersect B, so it's the same thing on the top actually. But on the bottom, instead of, so here we're going to have A, so this on the bottom is going to be the probability of A. So we want the probability of B given A is this divided by that. So we need the probability of, we need the probability of B given A. I'm sorry. We need the probability of B intersect A. We already did that because that's the same as A intersect B. So we already did that. That's 310. So we need the bottom part, which is the probability of A. So going back to this table, the probability of A, what is A? That it was male. So what is the probability of A? Well, there are three ways that it could have been male. Where are they? This one, and this one. So the male cases are 620 out of 1100. So it's this plus this plus this out of 1100. 620 out of 1100. Okay? So the answer is going to be this divided by this. We just did these calculations. It's this over this becomes 31 over 62, 1/2. Okay? So the answer to question A was this number, and question B was the reverse of this question, B given A, and the answer was different, of course, and the answer is 1/2. Okay, one more thing here. This is the definition of conditional probability. Now it's not very hard to see that you can bring this over to this side, and then you get probability of A intersect B equals this times this one, which is what they write here. The probability of A intersect B equals the probability of B times the probability of A given B. Okay, so you can write this if you like. And this is another this is an expression for A given for the probability of A intersect B. Now, actually, we didn't have any expression so far for the probability of A intersect B. We had three rules before. One was the probability of A union B, and a second rule for A union B when they were mutually exclusive, and we also had the probability for A complement. So we didn't have any rule for A intersect B, so now we have a rule for A intersect B, and it's in terms of conditional probability, in terms of this statement.